Hello, in this video, look at the introduction to organic chemistry. So knowing that organic chemistry, it's a type of chemistry, or it's a branch of chemistry that deals with the organic compounds. These organic compounds, they contain carbon and hydrogen. This is why they are known as hydrocarbons, because they only contain hydrogen and carbon. Others, they contain oxygen. These are alcohols, esters, and acids. We call them carboxylic acids. In today's video, I will just give a brief introduction about these organic compounds. Now, they are what we call the homologous series. The homologous series, it's a group of organic compounds which have the same functional group and same physical properties, with same chemical properties, but different physical properties. So these are what we call homologous series. So they belong to the same functional group, but they have different physical properties and the chemical properties are the same. Examples of homologous series are: 1, alkanes. I want to go deeper. I'll just give an introduction. Alkanes, these are homologous series that have so they have the same functional group, or they have the same chemical formula, chemical structure. So this has got N to N plus 2. So this is the general formula. So they have the same general formula. Also have the same functional group. So this is the general formula for alkanes. An example is methane. Methane has 1 carbon atom. So N is the number of carbon atoms. So if we have 1 here, we are going to say 1. H, 2 is 1 plus 2. The formula will be what? Will be 1. C, 2 times 1 is 2 plus 2, which is 4. So this will give you the formula for methane. Another one is ethane. Ethane has 2 carbon atoms. So it has 2 open brackets, 2 plus what? 2. So give you C2 and 6. They go up to methane, ethane, propane. Propane has 3. Butane. Butane has 4. We have pentane. Has 5, just like that. Hexane, and so on. Then we have the second one is alkenes. I'll end on alkenes. And alkenes, these they have the general formula of this. For example, we have now under alkenes we don't have methane. We don't have methane. We only have ethene. So ethene, which has 2 carbon atoms, so its formula will be 2H4. The same way we had that side ethene, that side we had ethane, but under alkenes you're just going to remove this A and replace with E. So we are going to have ethene. If we have propane under alkenes, under alkene you are going to have propene. So propene has 3 carbon atoms, so it's to be C3H6. So like I said, I'll end on alkanes and alkenes. How can you draw a display formula? Okay, of these 2 homologous series. For example, let's go start from alkanes. We have CH4, methane. How can you draw the display? So this is your central carbon atom. You start with it. How many hydrogen atoms? 4. So we are going to have 4 hydrogen atoms like this. So this is the display for methane. Part of ethane. Remember ethane had C2, 6. They have 2 carbon atoms, so we're going to have like that. Now these alkenes, they have a single bond, so just show by a single line. Then this carbon, there are 6 hydrogen atoms. That means this one has got 3, this one has got 3. Like that. What of for alkenes? Alkenes, for example, ethene. Ethene has C2H4. Now these, they have what we call a double bond somewhere between 2 carbon atoms. It's like this. So what happens? Since there are only 2 carbon atoms, so we're going to have a double bond. These are known as unsaturated. Why? Because they have a double bond. They have a double bond. A double bond is what makes them unsaturated. That means the number of carbon atoms, the number of hydrogen atoms is not fully used in the bonding of carbon atoms. So we have carbon and carbon, then 4 of those. What of for propene? Propene had this formula, if you remember. 6. How can you draw it? We have 3 carbon atoms. Now only the double bond should only be between 2 carbon atoms, not all the 3 carbon atoms. So first you write all of them. Then you choose which one should have a double bond. Mostly these 2. It doesn't matter, it's just you're choosing. We'll learn about isomerism. So that means Now this is when our things get tougher. We have 6 hydrogen atoms, so this should have 2, this should have 2, this should have 2, this should have 2. Now where do you put the remaining 2? So this has 1, there are 5. Where do you put the remaining 6? You put it here. Then this carbon doesn't get attached to any. It doesn't have any carbon attached to it. Why? Because already it has 8 electrons. This is 2 electrons, this is 2 electrons, and this is 4, because the double bond has got 4 electrons. So it cannot have another hydrogen attached to here. It only has 4 and 4. You understand? And how come we didn't put the hydrogen here? Even this one has 1, 2, 3, 4. So this is 2, 2 plus 4, which is 8. So just you can only put on this one so that it can also have 8. 2, 2, 2, 2, which is 8. Let's look at another one. Butane. Butane has this formula. I can write the display formula. So we have 4 carbon atoms. So we put our double bond there. Then we put single bond, single bond. We have 8. So first put, and at the end you also put, because this is what we know. This one is fully bonded. We have how many remaining? We have 6. Put there, and here put. We have how many? We have 4, 6. So we have only 2 remaining. So we put one here, so that this one is occupied. Then we also put another one here, so that this one has got 1, 2, 3, 4, 8. This one has got 1, 2, 3, 4, 8. This one has got 1, 2, 3, 4, 8. This one has got 1, 2, 3, 4, 8. So that's how you can do the distal formula of all alkanes and alkenes. See you in the next video. This is just an introduction. The next we'll look at properties of these reactions and many more.